Okay, so we start with page 1, which has midpoint and distance. So Luke, those are 2 that you need to know. They're obviously not on your 5 reference sheet. Those are 2 of the equations, or 2 of the formulas that you want to make sure you know. Midpoint and distance. Here's graphing a line using slope-intercept. We talk about domain here. Remember, domain has 3 scenarios. One is if there's a variable in the denominator, like this case. And for those, we set the denominator not equal to 0. Just like this one. This is multiple choice, so the good news is it's not like you have to like figure out if it's supposed to be in interval notation or not. It's multiple choice, so it will be in interval notation. If there was the variable underneath the square root, then we set that greater than or equal to 0, and then if there's a variable underneath the square root in the denominator, then we set it equal to 0, or greater than 0. So those are domains from an equation. Then you get into like the function notation. So number 4 has f times g. Number 5 is f plus g, f minus g, f times g again, f over g, and then f of g of x and f of g of negative 4. So remember that little open dot means you're going to start by plugging the g into, or plugging the negative 4 into g, and then taking that answer and plugging it into f. So I'll go back to that because all of those are on the next page, but yeah.
Wait, can you go for e?
Yeah. So then 6 was your inverse. Remember your inverse, you switch the x and the y, solve for the new y. 7 is the center and the radius of the circle. So you need to know the standard form of a circle and how to pull the center and the radius out of it. So remember the center, we change the signs on the h and the k, and then the radius, we square root the number that's there. So the center would be 6, negative 3, and the radius would be 8. Then came your i's. So this is your complex numbers. Remember that we treat them just like a variable, like x, except for when it's squared. When it's squared, it gets replaced with a negative 1, like in number 9. Questions on any of those? So E is here. Oh, E says. So what we're doing is taking G, what the function of G is, which was this, right? And we're plugging it into X. So F was this, and G was. So I take this entire thing and I plug it into all the X's in F, which is what this step looks like. And then because 1 is squared, you actually have to expand it and FOIL it out. So that's what this is, x squared plus 2x plus 4 times x squared plus 2x plus 4. FOIL that all the way out, and that takes x, that's all this. That all comes from the square of the first one. And then you distribute 2 to each of these, and that's this part. And then add the 5, which was there originally, and that's that part. And then just combine your like terms.
The midterm is going to go like kind of in order.
It sort of follows the order of this packet. So some things are like not in the order of your book. Certainly the calculator's not, because that kind of came sporadically through it. So it's not perfectly in the order, especially because all the graphing's at the end. But like overall, it kind of follows the order of this, which kind of follows your book. Yeah.
In the calculator, multiple choice too, right?
Yes. And it is just the first 4 questions. So the only open-ended are graphing. And it's a big chunk of your grade. So you want to make sure you know what you're doing when it comes to that graphing. Like it stinks to get all the way through all those multiple choice and then get to the end and lose a huge chunk of points because of your graph. So don't do that. Okay? Okay, 10 was dividing that complex number. So you have to multiply by the conjugate. In this case, it's 4 plus 3i. Again, it's multiple choice, so you won't see it both ways, but you will see it split up. So remember that these you're going to split up and you're going to see if you can simplify them. If obviously you can simplify them, you need to. If not, you can keep it the way that it is. But the format would be split like that. Number 11 is max min. So it has a max if the x is negative and pointing down. It has a min if the x squared is positive and pointing up like this one. And then I found the vertex by doing negative b over 2a. Plugging that back in to get the y, and that's where your maximum point or your minimum point is going to come from. So there's 2 parts to that. Is it a max? Is it a min? And then what is the actual value? And that's going to be from the vertex. I think it's way easier to do negative b over 2a than it is to force that in to complete the square. But if you completed the square, you would also get the same answer. Number 12 is leading coefficient test. So remember that if the highest exponent is even and positive, then they both point up. If it's negative and even, then they both point down. If it's positive and odd, then it points up to the right and down to the left, or rises right, falls left. And if it's odd and negative, then it rises to the left and falls to the right. So in this case, you look for the highest exponent, which is first. It's odd, which means one's going up, one's going down. And it's negative, which means the left side is rising and the right side is falling. 13, you're going to be factoring and solving that. 14, you're finding the zeros. So you're factoring, if it's not already factored, solving it. And remember your multiplicity. So if it has, the multiplicity is what? How do you find multiplicity?
Factor it.
And then what makes it a multiplicity of 2?
The powers.
It's the number of roots, right? So the number of roots, or actually I should say the number of times a root appears. So because we have 2 zeros here, the multiplicity there is 2. There's only one positive root 5, one negative root 5, and 1 9. So the multiplicity on those are 1. If the multiplicity is even, then it bounces or turns at that point. If it's odd, it crosses through. $15 is long division. Obviously, you're going to be forced into doing long division. And then 16, synthetic. Just be careful with your signs on that stuff. 17, if the equation gives you 1, 0, which is this case, you're going to take that. You're going to put it on the outside of your synthetic division. Reduce your polynomial a degree, which makes it quadratic. And then you'll either be able to factor it from there or use the quadratic formula. So that's another equation you want to make sure you know, quadratic formula. So midpoint, distance, circle, quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, vertical asymptotes. So vertical asymptotes come from your denominator. And set it equal to 0. In this case, my vertical asymptotes would be at x equals 4 and x equals negative 2. Horizontal asymptotes come from the degree of the numerator and the degree of the denominator. So if n is the degree, which is the highest exponent of the numerator, or the top, and m is the degree or highest exponent of the denominator, then there's 3 separate situations. If they are equal to each other, then it's y equals the leading coefficient of the numerator over the leading coefficient of the denominator. If n is less than m, then y equals 0 is your horizontal asymptote. And if n is greater than m, there is no horizontal asymptote. There could be a slant, okay, but there's no horizontal. So in this case, if you look at the highest degree in the top and the bottom, they are the same. So it's leading coefficient in the top, which is 4, over leading coefficient in the bottom, which is 2. Y equals 4 over 2, which is 2.
Will there be same asymptotes on the test?
Well, you have to say that again.
Will there be same asymptotes?
No,
on the test?
no. If it's not in the packet, it's not on your test. Questions? Okay, then came graphs. So again, if you want to put like a star next to it, obviously this is an open-ended, this is an open-ended. And these have a little bit higher weight. These are double of the regular questions. So you want to make sure you know how to do these. For the exponential, I just plug in for x. So I set up a t-chart, I plug in -1, 0, and 1. I get 3, 1, and 1/3, and then I plot my curve. For the logs, remember the logs, we plug in for y. So notice that my y has the -1, the 0, and the 1. We would take y equals log base 5x minus 1. The small number comes over and picks up the y that's on the side by itself. And then I would solve for x, and I get 5y plus 1 equals x. And then I take each of these points and I plug them into the y. So 5 to the -1 is 1/5 plus 1 is 1 and 1/5. 5 to the 0 is 1 plus 1 is 2. And 5 to the first is 5 plus 1 is 6. And then you plot those points. 22, you're actually saying what power do I raise 3 to get to 1/9? To make it move to the denominator, my exponent has to be negative, and then to get it from 3 to 9 means it's got to be squared, so that'd be -2. You could actually expand that too, like if you would rather do log base 3 of 1 minus log base 3 of 9, that works too. This would be 0 minus 2, which is -2. There's a lot of different ways to do the logs. 23 is ln of e. Remember, ln of e cancels and leaves you with the exponent. So it would just be 16x. Then comes expanding and condensing. So this generator just says like expand, but it means expand or condense, and the same thing's going to happen on your test. The directions are the same. It means expand or condense. So if it's already with 1 log, then you're going to expand this out. If it's got more than 1 log, like number 27, then you're going to condense it. Remember that when it's multiplication and you stretch it out or expand it, it becomes addition. When it's division, it becomes subtraction. The power goes to the front, like this will eventually become this. Well, actually, ln of e cancels out to give you 6. But if you had just bumped to the front, it would be 6 ln of e, which is 6. 26, expand it, would be log base w of 11 plus log base w of x minus log base w of 2. And then 27, you're condensing. So now the number on the front is going to go to the exponent. That would become a to the 5th. The 5 goes to the top. That would be b to the 5th. And then there is 1 ln when you condense a to the 5th over, a to the 8th, sorry, over b to the 5th.
Can you send it to number
26, sure. Like the answer? Or the work?
The work.
So when you separate it out, this one becomes multiplication. Or that is multiplication, which becomes addition. And then the over 2 becomes your minus.
Thank you.
You're welcome. All right, 28, solving, again, now we're doing exponential. The 27 to do change of base there, 27 would be 3 to the -3. Once the exponents are the same, or once the bases are the same, you can set the exponents equal to each other. 29, you have to condense first. So you have 2 logs on one side. You're going to condense it as in multiplication, and you get this line. Then the 4 comes over and picks up the 2, and you get this line. That becomes 16, and then you get everything to one side. Remember, you can't have it equal 16 and then factor it out. You have to set it equal to 0 before you can factor it and split it and solve it. And then this actually says be sure to reject any value that's not in the domain, but remember that when you have logs, you have to check your answers. When you plug these back in, if I plug in 3, it's fine for both, but if I plug in -7, I end up trying to take the log of a negative number, which doesn't work, which is why you cross out -7 and only keep 3. So you'd also have to check 30. Everything that has a log in its initial equation, you have to check your answers. 30 is the 1-to-1 property. There's 1 log on either side of your equal sign. You just have to set them equal to each other and then solve. Questions on those? Okay, 31. This is -105. So you go negative, which means you'd start at 0 here, and then you'd work your way back around this way, just past the 90, and you get negative 105. If you downloaded the original solutions, this said quadrant 2. That was wrong. This is quadrant 3. So make sure you made a note of it. 32, positive angle less than 360, that's coterminal. So coterminal, this is in radians, so I'm just going to subtract 2 pi until I get it in between 0 and 360. I only had to do it once this time to get it to be pi over 6. 33, secant is the reciprocal of cosine, so I'm going to take the x, I'm going to flip it, and then I had to rationalize it. 7 root 33 over 33. 34, cosecant of 7 pi over 2 is going to be the reciprocal of sine at 7 pi over 2. So 7 pi over 2 becomes 3, and pi over 2, that's at the bottom where your points are 0, negative 1. Sine is negative 1, flip negative 1, it's still negative 1. 35 says use reference angles to find, this actually, somebody asked about this yesterday too and I didn't catch it. This is the reference angle, but it says use the reference angle to find the exact value. So you're actually looking for the sine at pi over 3. This answer should be root 3 over 2. (36) This is your inverse trig functions. So remember for sine and tangent we use the fourth and the first quadrant. So we use the negative angles down here. Into the first quadrant. And then for cosine, we use the traditional 0, first quadrant and second quadrant, 0 to pi. So this is where you're given the trig function and you're looking for the answer, right? So where is sine negative? Where would be sine root 2 over 2, and that's pi over 4? Where would cosine be negative root 3 over 2? That's 5 pi over 6. And where would tangent be negative root 3? And that's negative pi over 3. So you'll get given the unit circle, but remember if you wanted to add in your tangents, that tangent would be 0, root 3 over 3, 1, root 3, and undefined for that first quadrant. So all the over 6s, it's going to be root 3 over 3 because it takes 2 3s to make a 6. All the over 4s are 1 because the x and y are the same. And all the over 3s are root 3 because there's only 1 3. Okay, 39 is your triangles. So 18, 24, the missing side there is 30. And then you got to find cosine. 40 says to use a sketch to find the exact expression. So you're using the inside information to form your triangle, finding the missing side, which in this case is the square root of 85. And then you're finding the trig function on the outside of that same triangle. So I want to find the cosine of this triangle, which would be 9 over root 85, which gets rationalized to 9 root 85 over 85. Questions on that one? Okay, 41, this is your sum and difference formula. So these are on that reference sheet. Okay, it's sine, so I break it apart into 2 angles. This time I did 30 and 45. Remember that this, because it's multiple choice, this order could be different. It could be root 6 plus root 2 over 4. So just notice that that's the same thing. And then these answers are going to be written like this, where they take the root 2 out. So make sure you know those are the same things. Tangent, this time we're condensing, so you want to identify the pattern. If it was sine, cosine, cosine, sine, then that's sine, and you'd keep the sine. If it's cosine, cosine, sine, sine, then it's cosine, and you change the sign. And obviously, if it's tangent, but you match the numerator's sign. So this would be root 3 over 3. Okay, here comes more of your graphing, which means more open-ended. This is all transformation based. So these are approximations. I don't need exact points on anything that's transformation based. You'll be using a t-chart for the exponential and for the logs, and then you'll use obviously the information on your trig functions when you do that. But for these are just transformations. You can just use the approximation.
And then 41 is supposed to be sine 30, cosine 45 plus cosine 39, and then sine.
Yeah, I think I wrote this. This is sine, cosine. 30, 45. Is that what you're saying? I just switched these two. It should still be the same answer.
Okay.
Yeah. All right, so again, 43, 44.
For 41, if we don't like change it to the, like for the answer.
It's multiple choice, so this will be the only answer that's there. The other one won't be there. 45 is still graphing, so again, all of this is open-ended. These trig function ones are worth 5 points apiece, so you want to make sure you know how to do sine, cosine, tangent, cotangent, cosecant, and secant. So this is just 2 of the 6 that it could be. Remember, sine and cosine is where we do the amplitude, the period, and then the quarter, half, 3/4, that kind of stuff. Then came tangent and cotangent. Tangent, we set it equal to negative pi over 2, positive pi over 2, and then subtract the period, add the period. Cotangent, we set it equal to 0 and pi, subtract the period, add the period. Those are your asymptotes. And then the last ones were cosecant, which you're going to graph sine, and then do your asymptotes. Secant, you're going to graph cosine, and then do your asymptotes. For these, you need 4 asymptotes and 3 curves. Yep.
For 42 through 43 through 45.
Okay, then comes your verifying. So keep in mind that this, or completing the identity, this is going to be multiple choice. So it's almost like a matching in that way. That should be helpful, okay? So your answers should be there, and you got to figure out which one it is instead of just going in blind. But those are all going to come from your reference sheet. So I'll give you the identities. You just got to make sure you know how to use them. That would be like 48, 49, 50, 51, like all those. Oh, that's a repeated question, right? 51 is the same as 49. Yeah. Then this is the calculator portion. So all this stuff, this actually comes first. Okay, you're going to get that first. There's only 4 questions on your calculator. Be careful. Make sure you're paying attention to the mode. Okay, if you get a question like 58 and it said 1.6 degrees, you need to make sure you're in degrees. If it says 1.6, obviously that's radians. If it's got pi in it and no degrees, that's radians. So you got to make sure that you're careful. So this one would have been in radians, but these were in degrees. This one doesn't matter because you're not hitting a trig function. It only matters if you're hitting sine, cosine, or tangent. And then this one, remember, your inverse is always in radians. So whether it said sine -1 or it said arc sine, those would be the same thing. And those you're always going to do in radians.
The compound interest formula would be on the.
Yeah, so just like it's in the instructions I gave you both, you have to figure out which one you're going to use. It's the same thing. Yep. And then thing was the double angle and the half angle. So 52 is double angle. Remember, if it says 2 theta, that's double theta, which means double angle formulas. And then 53 is your half angle. So it probably will only ask for one of the 3 trig functions. You're not going to probably find all 3. Just be prepared for whichever one you're going to get, because you could get one of any of those.